Hello, grade 12. In today's lesson, we're going to be looking at financial maths. We have grade 12 questions, part 3, and we are looking at deferred payments. Let's see what question we have got. Question 6 says, Sandile bought a car for 180,000. The value of the car depreciated at 15% per annum according to the reducing balance method. The book value of Sandile's car is currently 79,866.96, right? So here we have a situation whereby Sandile bought a car at 180,000, but then it depreciated according to the reducing balance method. And now the car cost only just 79,866.96. Now, if you can remember from grade 11, if we have the reducing balance method, we know that this is simply just like the compound formula, just with the minus here. So we have 1. So what do we have here? We have 1 minus I, and then to the power of n. This is the reducing balance method. So here on A, here we have the book value, and then here the principal amount, which is the amount of the car before it depreciated. Now let's calculate that one. So we're just going to have A is equals to P 1 minus I to the power of n. And then what are we looking for? We are looking for the number of years. So what do we have here? So this is the amount of the car now, the cost of the car now. Then it was 180,000. Then we have 1 minus. Then we are given the percentage. It was depreciating at 15%. But we know whenever we write our percentage, we must write it in the form of a decimal. So we have 15 divided by 100, because the percentage is always divided by 100. Then we have 0.15. So we're going to put 0.15 here. And then what are we looking for? We're looking for n, right? So solving this one, we can just divide both sides by 180,000. 180,000, right? Now, if you put that in your calculator, it should give you something like, so you have this one minus 0.5. So, okay, let's just calculate what's inside here. So say 1 minus 0.15, it should give you 0.85, then to the power of n equal to, put that in your calculator, it should give you something like 0.444. So this one, if you put it in your calculator, 0.443, and a lot of numbers there. So knowing your logs here, you have to apply your logs, because here you are dealing with an exponent. So knowing your logs, you know that you have to have n is equals to log, then whatever that you had as a base there, it goes here 0.85. Then those numbers 0.4, 0.43705, blah blah blah. Then make sure when you write it in your calculator, you never erase this one, because we don't want your answers to be rounded off until you arrive to the final answer. So make sure you save your answers here, so that you can just insert them here, right? Then you have that. It's gonna give you 4.99 something, which if you round it off, it's just approximately 5, right? So how many years did it take the car to depreciate to that value at a rate of 15%? It took it 5 years, right? So it's 5 years. That's how you could have got the answer. Then 6.1.2 says, at exactly the same time that Sandile bought the car, Anil deposited 49,000 into a savings account at an interest rate of 10% per annum compounded quarterly. So note that, you want to note that whenever you are reading your statement and financial maths. So PA compounded quarterly. Has Anil accumulated enough money in his savings account to buy Sandile's car? Let's find out. So here we are given that obviously it was compounded. So here we have the compound formula. Then we want to get the accumulated amount, but then we know the principal amount was what Anil deposited into the account, 49,000. Then 1 plus, he got 10%, so that's 10 divided by 100, it's 0.1. Then since it was compounded quarterly, we have to say over 4 here. Then what do we have? We already have the number of years. It was 4 years. So we're just going to go 4 times 5. Oh, so it was 5 years. 5 years, pardon me. It was 5 years. Then we go 4 times 5, right? Because it was compounded quarterly. Then if you just punch that in your calculator, you get, so punch that in your calculator, you get 80,292.21. So now the question is, will Anil be able to buy the car? Since the car now after 5 years costs only 79,866.96, yes, Anil will be able to buy the car, or Anil has enough money to buy the car. Yes, Anil has enough. So Anil has enough money, right? So Anil has enough money. 6.2 says exactly 10 months. So this is where we get to these deferred payments. So exactly 10 months ago, a bank granted Jane a loan of 800,000 at an interest rate of 10.25% PA compounded monthly, right? And then what are we given there? We are given that at the rate of, so a loan of 800,000 at an interest rate of 10.25% compounded monthly. The bank stipulated that the loan must be repaid over 20 years and then must be repaid by means of monthly repayments of 7,853.15, starting 1 month after the loan was granted. So we know with the loan, you pay it a month after you have taken the loan, right? So you cannot pay the loan just a month when you took the loan. Then here we are asked, how much did Jane owe immediately after making her 6th payment? How much did Jane owe after making her 6th payment? Now let's check. So how do we calculate that one? So first thing we know, this is a loan, so we must obviously use the present value formula. We must obviously use the present value formula. So for this one, we are asked here, how much did Jane owe immediately after making her 6th payment? So you can see with this one, this is an outstanding balance kind of question, because here we are asked about the amount she owes after making the 6th payment, which means we are required to calculate how much she owes for the coming months, right, after making that 6th payment. Now, if you can check here, our period is 20 years, which of course, since we are compounding this monthly, we have to know how many months are in 20 years. So we have 20 times 12, right? So 20 times 12, it's gonna give you 240 months, right? So she must make the payment over 240 months, right? Then now we are told that after the 6th payment, that means we're gonna just go 240 minus 6, then we check the remaining months. So it's 234. So the outstanding balance is over 234 months. 234 monthly payments. So what are we going to do now? We're just going to go P, X, write out the formula as it is. Write out the formula as it is from the back of your question paper. Then there you go. What is my X? I've been told the monthly payments was 7,853.15. Took that from the statement, right? Then 1 minus 1 plus. What is the interest rate? 10.25%. So divide that by 100, you get 0.1025. Then divided by 12, since we are compounding this monthly. And then how many months do we have left after making the 6th payment? It's only 234. So she must make 234 successive monthly payments. Then 0.1025 divided by 12. Now punch that in your calculator, you'd get her outstanding balance for the remaining 234 months, which is the money she has to pay. Then 793,749.25. So 793,749.25. That's the amount she owes after making her 6th payment. Then let's check the last question. What does it say? It says due to financial difficulties. So we know this one. You might agree with the bank that you'll pay those amounts, but then there's a lot that could happen. You could lose your job. You could face other financial difficulties, unforeseen circumstances. So this is what we are told about here. 6.2.2 says due to financial difficulties, Jane missed the 7th, 8th, and 9th payment. So how many payments did she miss? 3 payments. So for 3 months she didn't pay. She was able to make payments from the end of the 10th month onwards. Calculate Jane's increased monthly payment in order to settle the loan in the original 20 years. So we know since she's missing the payments, the loan will increase, right? Because the loan is like accumulating interest for every month, right? Whether you pay or you don't pay, the loan is accumulating interest. So the first thing we must do there is to calculate the interest that was accumulated over those 3 months that she didn't pay, right? So we're gonna go, what's the amount that we have? 793. So if we can just calculate it here, 6.2.2. So we have A, P, we're just gonna calculate it using this one, compound. So now we have 793,749.25. 1 plus, what's the interest rate? 0.1025 over 12. Then how many months? 3 months, right? 3 months. So this is 1. Let me just write it nicely here. This is 1 plus 0.1025. Then punch that in your calculator. Punch that in your calculator. How much do you get? 814,263.3052. So I'm just gonna write this like this because it's not the final answer. So I'm not trying to round off anything. 3052, right? So as a result of her not paying for those 3 months, the 7th, 8th, and 9th month, now her loan has increased to 8,014,263.3052, right? Now let's check we must calculate her monthly payments because now she must pay the loan over 20 years still, right? She must pay the loan over 240 months still. So now that means since she has lost this, since she has skipped those three payments or those 3 months, now she must have an increase on the what? On the monthly payments. She cannot be paying the same monthly payments because now she has missed some of the payments, but then the period to repay her loan is still the same, right? So now what are we going to have? P is equals to X 1 minus 1 plus I. So still using this one, we are dealing with a loan. So now what are we calculating? We are calculating the new monthly payments. Now what is the new amount on the loan? It's no longer that 800,000. It's that one. Is equals to X, then 1 minus 1 plus, what's the I? 0.1025 divided by 12. Now let's come to the months right now, because this is a challenge to a lot of you, right? Now we must understand that he's starting to make payments, or she's starting to make payments from the 10th month, and then she must get to what? The 240th month, right? So now we know how many months are in between there. You can just simply assume 240 minus 10, then you get 230 months. But that's not how it works. You have to remember that from here, she's starting at the 10th month, so we have to also count the 10th month. So we're just going to go 240. So remember, when we are looking for n, the formula is n is equals to the upper value minus the lower value plus 1. So what is our upper value? That's the final month, 240. The lower value, that's the month when she starts resuming on paying the loan, which is the 10th month. But then we have to come and say plus 1 because we are also counting that month when she starts to resume. So she doesn't pay on the following month after the 10th month. She starts on the 10th month. So it's 240 minus 10 plus 1. Then the number of months that we should have there, or the monthly payments, it's not 230 but actually 231, right? So be careful with that one. Be careful with that one. Always draw your number line and then remember this formula: upper value minus lower value plus 1. So what do we have for our end here? Negative 231. Negative 231. So it's a negative, then close bracket like that, over 0.1025 over 12. Then what are you supposed to do from now on? You can just cross multiply. Take this one, cross multiply it with that one. So let's do our math. So I'm gonna end up with X equals to 814,263.3052. Then cross multiplied it with 0.1025 divided by 12 all over 1 minus 1 plus 0.1025 over 12 to the power of negative 231, close bracket. So just punch that in your calculator, see what you have. Punch that in your calculator, it's 8,089.20, right? 8,089.20 cents. And that's how you could have solved that question. Nice one.